Good morning, everyone. We're ready to start. Thanks for joining this webinar. It's the latest in our series of Power Talk webinars. I'm Kobe Chinathambi. I'm one of the sales engineers at Freedom One. And today we're going to focus on our industrial and utility grade inverter solution, which is the EPC Power CAB1000. A little bit of background on Freedom One. Freedom One was established in 2010, and we are the oldest and largest manufacturer of lithium iron phosphate batteries in Africa. So Freedom One in the numbers, our facility has the capacity to do 3.5 gigawatt hours per annum. Our product range, we have 11 unique product ranges to cover various solutions from residential up to utility scale projects. And we have in excess of 150,000 units sold per annum. And in the picture on the right, you can see a picture of our facility here in Longmeadow Business Park in Johannesburg. And it's a 48,000 square meter facility. Currently, we have in excess of 350 employees. And just to take us through this interesting product, we have two of our in-house gurus, Isaac and Hein, that's going to take us through the features and benefits of the EPC Power CAB1000.
All right. Good morning, everyone. My name is Hein. I'm an R&D engineer here at Freedom One. So, as Kobe mentioned, we're going to talk about the EPC Power CAB1000 today, which is a large-scale utility-grade, industrial-grade hybrid inverter. Paired with our battery, we get 1.4 megawatts of capacity. It's an inverter. It's developed in and manufactured in California in the USA. And it has a known track record for very big installations, multi-megawatt installation with a reliable operation. Some of the reference projects we can quickly talk about is 227 megawatt installation in Lancaster, California, which is one of the largest battery storage facilities in the world. Then there's a 300 megawatt installation in Arizona, and supporting Finland's national grid is a 90 megawatt installation in Finland.
Yeah, thanks, Hein. Just to also mention a few, we currently have a 1.5 megawatt system that is currently supporting a factory, a packaging factory in the Western Cape. We also have two projects that are currently running to support a shopping center here in Joburg, and one which is earmarked for Antarctica as well. So we're pretty much excited with this rolling out the CAB1000.
Yeah, thanks for that, Isaac. So some of the unique selling points of this inverter is it's a very scalable platform, configurable from 1.4 to 5.6 megawatts on a single isolation transformer. And then you can use those modular clusters to build bigger capacity should you need to. The system is designed with redundancy in mind on its internal components, and it's designed for greater than 99% uptime. It's quite a versatile solution that can be used in various applications, but some of the key features are black start capabilities, supporting a microgrid by being grid forming, very fast adjustments in frequency. And then another versatile selling point is it's a weatherproof cabinet with its own environmental management system to manage the environment on the inside of the inverter with a cooling system and or heating as well for cold climates. Can be used in multiple sectors from utility to agriculture. The system can be integrated with a throat connected option, where the bus bars run through the middle of the inverter and then connects to your isolation transformer. Or there's the non-throated option where the cables terminate on the bottom through a trench. Some of the advanced technology it has built in is a high short circuit capability on the DC and the AC side. It can act as a virtual synchronous generator with synthetic inertia, and it can also assist with power quality downstream. Another important feature is the 4-quadrant operation, which means it has an extended reactive power capability to inject up to the rated capacity of reactive power into your load, which can also be used for power factor correction. It's a very efficient inverter with up to 99% conversion efficiency, depending on load conditions. Also quite a flexible solution that can be used for microgrids, off-grid solutions, grid-connected systems, utility applications. Can be used for voltage regulation on grid lines as well. And moving then on to the next slide, we can go into a bit more detail. There's several key advantages. As mentioned, utility grade applications. It has a very high DC bus voltage, quite a bit higher than our other commercial solutions. The inverter transitions from grid following to grid forming in around 2 milliseconds. That doesn't mean your site's load is transitioned within that time frame, but the inverter transitions internally to become grid forming, and then depending on the site's load and reactive power being demanded, it will take a certain amount of time for the inverter to recover the bus voltage. And it also depends on the external switchgear of the site. It has been proven up to 200 megawatts, as explained earlier. So essentially, these 6 megawatt clusters can be paralleled indefinitely to build the capacity that you want. The operational temperature range is from -20 to 60 to positive 60 degrees. And then there's a cold weather option to operate down to -40. And it can be put outside, it's weatherproof. And then the cold weather option has covers and ducting for snow applications as well, which I don't think we're really going to use in South Africa, but it's there if you want it. We are compatible with multiple control systems, including the Freedom One EMS Pro, and in theory, any third-party controller that the customer may need to design. Because it's quite a big building block for up to 1.4 megawatts, it reduces the necessity for paralleling multiple smaller inverters, which have their own limitations. As mentioned previously, there's demand response features such as frequency regulation, voltage regulation. There's also a black start capability provided, which is a requirement for that is to install auxiliary power for the control and cooling system for the inverter. And that is backed up through a UPS. And then also, as mentioned previously, when on grid, you can generate excessive reactive power to correct the power factor of the load, because the inverter can operate in all 4 quadrants of the power circle. For solar integration, you have to use AC coupled. so that you connect on the AC bus to charge the battery. And then, as mentioned previously, the parallel option is with a throated connection, as shown in the picture. Can parallel up to 4 inverters with the throat option, and then up to 6 inverters with the non-throated option.
Thanks, Hein, for taking us through the key advantages of the CAB1000. As we can see, it's quite a scalable inverter and suitable for microgrid application. So we're going to look at some of the system components which are required when rolling out the CAB1000 into various projects. One of them that's very important is the isolation transformer. So this needs to be spec'd correctly to match the application to be integrated with the CAB1000. So the AC connection on the low voltage side, which is connected to the inverter, typically the inverter has a range of 480 to 690 VAC, which will be coupled on the low voltage winding side. Then on the secondary side, high voltage winding side, it will depend on the system voltage that needs to be integrated to. So there's also other technical considerations when selecting the transformer, looking at the transformer impedance, the K factor, the harmonic tolerance, and also it needs to be suitable for renewable energy projects. So when during the design phase of the project, we are able to provide all those technical requirements to ensure that the transformer is spec'd correctly. Also, the switchgear, it's quite important that it's selected correctly for protection, safety, and operational control. This is quite critical, especially when you're using the inverter with UPS functionality protected bus to allow the seamless transition. Then we need to ensure that the switchgear is selected correctly, because the transition is also dependent on the type of switchgear that is integrated. The inverter requires a plant controller, basically to send and execute commands based on the system requirements, as the inverter requires an external plant controller to control. Then the base frame, it's mostly required for skid application, whereby the integrated inverters into a cluster can be connected via throat connection to a transformer. And basically, those clusters can be positioned anywhere and integrated together to form a large microgrid plant or application. Then the battery compatibility, the inverter is compatible with our Mega Tower Extra. So you need a minimum of 2 batteries for a single inverter to get the full 1.4 inverting capacity. So depending on the storage requirement, your energy storage, then obviously you can scale the inverters. You can connect more batteries on one inverter. But the minimum requirement to get the full inverting capacity is 2 Mega Tower Extras. Then looking at some of the considerations when speccing the system, what you need to understand is your usable energy storage required, which will basically influence your battery sizing. Then also you need to understand your peak load. Your peak load will help in terms of sizing the inverter correctly. This goes hand in hand with the load study performed. The load study performed helps in terms of understanding the characteristics of the load and ensuring that the system is designed effectively and will be able to meet the client requirements and function seamlessly. Then if you've got your on-grid or off-grid hybrid system, also it translates to what will be integrated with the CAB. If there's any other external sources, such as your grid-tied inverters, your wind turbine, or your generator integration. So we need to understand how those are going to be integrated in order to design the system to function as a hybrid. Then if you've got PV, obviously we need to understand the kilowatt peak. Normally, if you've got a 1-to-1 ratio, it works quite well, because as soon as you lose control of your grid-tied inverters, then you don't have high power that can be injected back into the inverters. So if you've got higher kilowatt which is installed in terms of the grid-tied inverters, then you run the risk of injecting more power than the rated capacity of the hybrid inverter itself. So it's very important that the PV is sized correctly. Also, the control is implemented optimally to ensure the system functions efficiently. Then generator integration also can be integrated on the output side of the inverter, meaning it will synchronize to the load bus of the inverter. In such situation, a sync panel is required in order to control the generator as well, being integrated and using the inverter reference voltage to function. So these are very important key things that you need to consider when speccing a system to ensure that it's designed optimally and it functions in a manner which meets client's expectation and seamlessly. So looking at the warranty terms and lead times for the CAB1000. So the CAB1000 comes standard with a 3-year warranty, and you've got an option to extend up to 5 years. So from the time the order is placed, we're looking at 16 weeks lead time, which also it depends on the volume, also the scheduling of the project. So our sales team will be able to advise and give you the relevant delivery timelines in line with your project. And some of the certifications which are mostly required for South African application, we've got the NRS 097 for category A3. Then we've got your battery energy storage facility grid code connection for category A3 and category B3, which is for larger system. Then some other certifications which are advantageous and speaks to the robustness and how the product has been tested. You're looking at your UL 1741 certification and other IEC certification, which the inverter has undergone. So you can see that it has been robustly tested for this application. So we're excited about this inverter, and we're looking forward to rolling as much projects as possible to ensure that we meet your needs and your demand in the energy space. Now I'll hand over back to Govi.
Thanks, Isaac. Thanks, Hein. Very useful information there, and quite a robust product compared to the commercial inverters that we are used to. So I just want to run through why choose Freedom One. I think the first thing is we are based here in South Africa. Our products are locally designed. We have a full engineering team and manufactured in South Africa for the African climate and the African market. We also have a full after-sales support team and services team at our head office in Johannesburg, but also some service support in other parts of the country as well. And importantly, our R&D team is based here in Johannesburg. So in the event there's special applications or special requirements, we can liaise with the team and see what sort of solutions we can come up to meet your project requirements. As far as our availability of our products, we have a network of distributors and EPCs around the country that you can contact for the standard product offerings. And lastly, Freedom One has been around since 2010. We have a lot of units that have been in service over the years in the market. And sometimes I joke about it and say we're one of the battery manufacturers in South Africa that actually have been around longer than our warranty. And I think that's important. So here you can see our contact details, and with the CAB1000, generally these are larger scale projects with a little more complexity. And we have a full engineering team here, and we are happy to have meetings on your projects to help you with pre-engineering so that the equipment can be designed for your requirements and help you through the project phases from pre-engineering all the way through to commissioning. So, yeah, in the next webinar in the series, we're going to focus on the Freedom One EMS, which is our in-house developed energy management system. That will be happening on the 18th of March. So just keep a lookout on our social media channels and please register for the upcoming Power Talk. So I think, Isaac, let's have a look at any questions that we have in the chat. So I'm just going to have a look at that quickly. So Max had a question. In terms of support, what is the standard warranty on the unit? And should there be an issue with the unit on site, what is the support protocol regarding this going to be?
So just to answer, Max, the standard warranty is 3 years, expandable to 5 years. So if you've got any issues with the inverter during the warranty period, then you're guaranteed full replacement of the components on site, should there be a problem with the unit.
Thanks, Isaac. We've got one more question from Repower. What are the inverter capabilities with inductive loads in an off-grid scenario?
I'll take this one. So the inverter obviously has full reactive power generation capabilities. So it can supply any inductive load. The only caveat here is that during the transient stage of when the load is started up, the bus voltage will drop depending on how big the inductive load is. But the inverter won't trip out. It will just bring the bus voltage back up once the reactive power has been consumed by the load.
Yeah, just to add on also on that, it's important to understand that when the inverter is sized correctly, as long as if the transient load spike doesn't actually exceed the inverter rated capacity, then it should be able to recover without any issues. So it's very important to do a load study to understand the characteristics of the load in order to determine the correct sizing of the inverter.
So in theory, what you're saying is, if it's a 1.4 megawatt inverter, it can supply reactive loads up to 1 year's capacity.
Yeah, correct. So there's a number of factors also depending on the AC voltage that you select and also your DC voltage as well, which influence the amount of reactive power the system can actually generate. So during the design phase of the project, we are able to provide the PQ curve for that specific project with a specific AC voltage and DC voltage, and which will determine how much reactive power we can generate. So it will vary depending project by project based on the AC output voltage selected.
Thanks, Isaac Han. That's impressive, eh? Let's see if there's any other. Will in-depth and in-person training be provided on these units? Yeah, I mean, if you an end user, right here in Johannesburg, we have a full training department that can do specific training on products as well as training tailored to your project and your installation if required.
And also keep in mind, Freedom One is certified to commission these inverters and do technical support on it. So Any support you need will come from us primarily, and then should EPC Power need to get involved, we will involve them.
Okay, we've got another question. How do we deal with units that are shipped outside of South Africa?
So we'll treat it like any other project. We'll offer support in line with the client requirements. In terms of our warranty, we'll honor that if there's any spares that need to be changed and so forth, because we currently do that with our normal hybrid inverters that we roll out. We do offer in other parts of Africa the same warranty, also the service support if it requires that a technician be on site to offer a first-hand support as well.
Thanks, Isaac. We've got another question from Willie. Is there reports / data on the inductive load capability? I think that should be in the specification sheet, depending on the voltage. So maybe you want to add on that?
Yeah, correct. So I've got a power quality report for the cab, which one can actually use to see in terms of how the inverter is able to react under certain conditions. So that can also be useful in terms of sizing a system. In cases where you've got a complex load or load profile, then it might necessitate also a load study to understand how, when modeling the system with the cab, how it will actually behave.
Thanks, Isaac. We got a question on the transformers and switchgear. So are there any future plans for you to partner with suppliers for rebuilds, or do you have preferred manufacturers?
So we do have, in terms of manufacturers that we have earmarked that we can actually work with in terms of integrating transformer a skid solution. We currently have a skid solution that we offer as a single product, which includes the cab integrated through a throat connection, then with a transformer and on a skid as a product. So we have specific manufacturers that we can work with in terms of supplying the transformer as well as the switchgear as well.
And it also very dependent on the project requirements.
Definitely correct. In some projects where the client might prefer to supply their own switchgear and transformer, and we are able to engage and understand and provide also technical guidance in terms of speccing the transformer correctly and ensuring that the system design will actually work with the cab.
Oh, understood. And I think the pre-engineering interactions for the project is very important to determine what's the optimum solution and equipment that needs to be spec'd on a particular project.
Right, yes.
So we've got another question on the sizing of the inverter and motor rating. So Ben said, should the inverter be 6 times the motor rate?
So I think Hein covered this on his previous response in terms of if you look at the motor, the amount of reactive power or that it requires during startup and the transient, it should be in such a way that it does not exceed the rated power of the inverter. In most cases, in such situation, if you've got semiconductor inverters, the most safest way to install a motorways through a VSD drive, then helps with maintaining system stability, reducing your total inductive load, and also improving your system power factor. So it's during that load study, one can determine what are your transient spikes, and from there on, one can actually make an informed decision in terms of how you need to mitigate some of those inrush and ensure stable supply.
Yeah, and I think from a cost perspective, installing variable speed drives on your larger loads is probably more cost effective than just oversizing the inverter to account for the inrush.
Correct, yes, most certainly. And it also helps in terms of maintaining system stability because you greatly reduce your transient spike during motor startup.
Just to add to that as well, this 7 times motor power rating for the inverter size is something that came from probably people's experience with ATES systems, where the inverter would trip on converter L over current when a motor starts, which I'm sure we're all familiar with. The difference with the CAB1000 is that if the maximum transient load is smaller than the inverter rated capacity, the inverter will not trip. However, the bus voltage will drop to supply that reactive power, but the inverter will just pick the bus voltage back up once the transient spike is finished. So that is the big difference here.
Thanks, Harry. We've got another question here. I think this is, we can take this one offline. So Jonathan just asked about the presentation. So I think, yeah, we will share recordings and of the presentation. It will be available on YouTube as well, the recording of the webinar. So if you missed it or if you think it's interesting for somebody else, you can refer them to our YouTube channel, and you can view the recording of this webinar and the previous ones that we've done as well. So we've got a question from Michael on Mega Tower regarding the discharge and charge rates. Do we have a document? Yes, Michael. So on our website, under the downloads tab, you'll find a full specification sheet for all our products. And you just go to the website, check on the downloads page, and you can find all the specification sheets on readily available. I think Sean actually responded to that as well. Yeah, I think that's the end of the questions.
We missed one from Repower.
Which one was that?
He's asking you recommend the inverter be sized correctly. In many cases, the site NMD is limiting the inverter allowed to be connected. So I think this refers to, Isaac, maybe you can help me here. If your NMD is, let's say, 1 MVA, are you allowed to connect a bigger inverter than your NMD? Yes. Your transformer?
Yeah, so basically we need to adhere to regulation in such an instance. In some the NRS actually specifies as well in terms of, and the grid connection code in terms of how the renewable energy inverters need to be integrated to the system. So it's just a matter of referring and adhering to those practice when running these installations. So it's quite critical to ensure that we meet regulations.
Yeah. And some municipalities might have different rules around that. It's more restrictive as well. So it depends on where the installation is as well.
Yeah.
I hope that answered your question.
Thanks, guys. Let's see if there's any more questions. There's a question for Isaac. Someone pick George.
They singled me out.
From what size application in terms of megawatt hour / megawatt should we consider the CAB1000?
I think anything in excessive of 1.4 megawatts and upwards, then this is a great solution. Then obviously for anything more than 2 megawatt, definitely you should consider the CAB1000. And if you've got power quality or weak grid, it's also a good inverter to take into consideration because of this advanced grid feature support that it comes with. And in some instances whereby the grid is very unstable and very weak, you have an option of doing a double conversion system to ensure that you supply seamless, stable power on the load side, while the primary inverters connected to grid are primarily introduced for charging the battery. So there is other options that one can look at, especially in systems whereby an uninterrupted supply is required.
Okay, and then thanks for that, Isaac. And exactly what you explained, the inverter can function on like a UPS in certain configurations.
Correct, yes.
Okay, thanks, Isaac. Then there's a question for me. So roughly how many CAB1000 inverters have been manufactured and installed to date? I think it's in excess of 300,000 units that have been manufactured, and that actually stats from a year ago. So I'm sure there's a lot more installed around the world currently. Okay, I think we don't have any more questions. Hi, and Isaac, thanks for this interesting webinar. Thank all you guys for joining. I hope it was informative. And please keep a lookout for the recording. If you want to share it with anybody else, just keep an eye on our social media platforms as well. We have the upcoming EMS webinar on the 18th. So I'm looking forward to seeing you guys back for that webinar. Thanks, everyone.
All right, thanks. Cheers.
Thank you. Cheers. Bye.